that costs nothing except air. Even air is even air is costing now, right?
Breathing expensive.
Okay, where were we in the last class?
We started with that chapter. Which chapter we start with
one
work and energy.
One on each test. Yeah, at least. Work and energy. We to start? Or we had started already? किसको देना था?
Sorry.
Okay, guys, return.
I'm gonna miss this paper.
Yes. Where did we stop in the last lecture? You were solving numerical problem.
We had solved the numerical that chapter, and as we started, the lecture ended.
Mass of moon. Mass of moon.
Mass of moon.
Sorry.
Acha, मतलब we had just started work and the lecture ended. That's what you're saying. So in work energy, did we define work? Did we define work?
No, we did not define it.
Okay. All right. So let's start with this chapter. This is chapter number 10. Yeah. New book, it should be chapter 10. Work and energy. Is there any question left in the last chapter? Did we do all?
We did do all.
Okay, fine. So this is an interesting chapter. Just like the other chapters that we learned so far. So not interesting? No. We spent so many lectures in motion and you're saying this. Huh? How many of you found motion not interesting?
Like it was a little confusing, not interesting.
Because that being the first chapter and suddenly the level changed, right?
Yes.
You're used to a spoon feeding kind of a stuff. But वैसा नहीं है. It will involve a lot of thinking now. Okay. Okay. Let's start with work. So what do you think is work? When you study, do you work?
Yes.
Huh? But that's not work in science. In science or in physics, like work is said to be done when any force acting on an object displaces it by some distance, let us say s. Right? So if the object is displaced up to this position, then we say some work is done on the object, right? So work is defined as force into displacement. This is the definition of work. It is defined as force times displacement, right? So W is equal to F into S. Now that motivates you. So the chapters are all small, okay? It's the concept, okay? So that you have to absorb. So let's write it in English. How do you write it in English? So work is said to be done by the force acting on the object if it displaces the object in its direction. Okay. So unless force displaces the object, work is not said to be done. Right? And this is how much work is done is given by this formula. Force into displacement. So what will be unit of work? Look at the formula on the board. Wake up girl on the last bench.
No, I'm not sleeping.
No, but you have to be in the right posture, right? What's the unit of work? What should be unit of work? Apply. I'm not asking you to read and tell me. Look at the board and derive the unit. So when you exercise your brain, you'll get the unit. So unit of work should be unit of force times unit of displacement, isn't it? Look here. Yes. Newton meter. Displacement is meter, right? So SI unit of work is Newton meter. Nm. We call this as joule. Okay. Also called Nm is also called joule. Okay. So how much is 1 joule?
1 Newton. 1.
So we'll say 1 joule of work is done when a force of 1 Newton, right, displaces the body by 1 meter. Now, is that difficult to understand? When 1 Newton force acting on this body causes to move it by 1 meter in its direction, then we say the work done by the force is 1 joule. Got it? Okay, that's what it is. Next, we will also say that work is a scalar quantity. Work is a scalar quantity. Okay, meaning it does not have any direction. Okay, work is a scalar quantity. But look here, force is a vector quantity, displacement is a vector quantity, but their product is a scalar quantity. Okay, so remember this, work is a scalar quantity. There is another unit of work which is CGS unit. Now, what is CGS unit of work? What is CGS of Newton? Dyne centimeter. Okay? न्यूटन का सीजीएस क्या होता है? डाइन. और मीटर का सीजीएस क्या होता है? सेंटीमीटर. Okay? So how much is dyne? Just like how much is Newton? So let's find out relation between joule and relation between SI and this is called or it is also called arc. 9 centimeter is also called arc. Now let's find out relation between joule and arc. Okay. So since 1 joule is equal to 1 Newton meter, this is equal to how much is 1 Newton? Kg meter per second square, right?
Yes.
Into this meter. Why did I write this? Since 1 Newton is equal to 1 kg meter per second square. This is the formula. Now substitute. How much is 1 kg? 1000 gram. How much is 1 meter? 100 centimeter. Second is second. Both essay. Again 100 centimeter. So how many zeros? 1, 2, 3, 4, 5, 6, 7. Gram centimeter per second square into centimeter. But what is gram centimeter per second square? Dyne. So this is equal to 10 raised to 7 dyne centimeter. Okay. So therefore, this is equal to 10 raised to 7 arc. This is the relation between joule and arc. Clear? So just converted this girl has constantly stopped coming and one boy, two boy, where are they? For them.
3 of them are there.
She's having continuous exams.
Mostly.
Earlier she was going to Bharatanatyam classes.
She just stopped showing up once ago.
Anna? She's not attending any lectures or just science lectures? Achha. Because her father told me, he met me during PTM, told me that she has to attend some other extracurricular classes.
But she stopped attending it tired.
Is it okay? Okay, relation between joule and so any difficulty here? What's her name? Adelina.
Adeline.
Adeline.
Yes.
Adeline. Okay. So this is okay.
Yes.
All right. Next is you have to understand. Now, don't we get tired whenever we are working?
Yes.
Okay. That means whenever we work, we lose energy. Okay. So any body which does work loses energy, and the reverse also is true. On any body, if you do work, that body's energy increases. Works both ways, right? So when you work on yourself, like when you feed yourself, you're working on yourself. So your energy increases. But when you work, that time your energy decreases. So there is a relation between work and energy. There is a parity. You work, you lose energy. Okay? When you are working. But when somebody works on you, you gain energy. Okay? So, note.
So the energy is energy, right?
No, this is ARG, CGS unit of work. You know CGS, no? Centimeter gram second. And this is SI unit, right? Where instead of centimeter it is meter, kilogram, second. Okay. There are different types of units. So when body does work, so this is the concept, okay? It loses energy. Okay. Second is when work is done on the body, it gains energy. Okay. So there are two things. Of yeah. All right. So it is the so here the force is constant. It's not changing. Like same force. Let's say 5 Newton. So throughout the displacement, the force is same amount. Okay, it's not changing. Constant force. All right. What is next topic? So question, right? These questions are okay. These questions are pretty simple. Do you want me to ask questions or shall I go ahead? So now let us define what is energy. I just said when body does work, it loses energy. Right? And when work is done on the body, it gains energy. But then what is energy? It is the ability to do work. Can you work without energy?
Yes.
Yes. So this is what it is. It is the, or it is defined as the ability to do work. Okay. Now what is its unit? Unit of energy is, so work is energy, energy is work, same unit. Unit of energy is same as unit of work. Okay? That is joules. So work and energy are interrelated. Huh? Without energy, no work. When you do work, there is either increase or decrease of energy. Okay? So work and energy are interrelated. Okay. Next is, what are the different types of energy? So we'll start from the start, right? Let's go 1000 years ago. What is the source of energy on this planet?
Sun.
Sun. Okay? So sun is the primary source of energy on this planet. It has been. So what is the first source of energy? Light. Okay? Light energy. Then speaking, right? So what are we? Sound. So we're talking about primitive days, before modern days. So sound was there.
Food. Water.
No. What other form of energy are we familiar with? Think about old days.
Earth's energy.
What did we discover then? Fire? Heat? Heat, right? So burn. Then we discovered wheel also, right? Motion, right? So motion is mechanical energy. Any moving body has energy. So it is called mechanical energy. So these are different types of energy, mechanical. Okay, what else? So mechanical consists of two parts, kinetic energy and potential energy. Okay, so mechanical energy is in two forms, kinetic and potential. So at any given instant, the mechanical energy of the body is sum of its kinetic and potential energy. We'll see in detail in this chapter about mechanical energy. No other energy will know, only mechanical. So what are the other forms of energy? Chemical. Any idea about chemical energy? You've not heard of chemical energy? When you burn coal, what are you doing?
Producing heat.
Yes. So you, by burning coal, you are producing heat. So burning is chemical reaction.
Yeah.
So chemical reactions are two types, exothermic and you have learned about it. So that is chemical reaction.
Last year.
कोई बात नहीं, इस साल पढ़ो. There's no escape. So chemical energy, right? Beauty about energy is one form of energy can be converted into other form. We'll see it shortly. What other energy type you are familiar with? So we are graduating slowly from the primitive forms of energy which were ever present, then heat, mechanical, right? Then you have chemical. Now, what is driving this light? Electricity, electrical energy.
Hydroelectricity.
Hydro is used to produce electricity, and hydro is mechanical, moving water. So mechanical energy of water is used to produce electricity. Okay, what else? There are various ways in which we can produce electricity. Right? There is one more form of energy called nuclear energy. Alright, I'm sure you've heard about all this. Not feeling well, huh? We'll have to sprinkle water on it.
I am not sleeping.
You were last week.
When did you return from school today?
It took me a while today because like we have a celebration tomorrow, right? So I just got home, changed and left for class.
You didn't eat anything?
What did you do?
Water you have? Have some
Forgot
water.
my
Have some water. Okay, so these are different types of energy, right? Now, have some water, go freshen up, come back.
No, it's fine. I'm staying.
Because looking at you, I'll also sleep. We
I'm
need.
just exhausted.
Okay. I understand. School से late आओगे तो ये होगा. Can I erase this part? First column. Shall I erase it?
Yeah, yes.
Kusul.
Welcome.
Okay. Okay. So in this chapter, we are supposed to learn only about mechanical. So let's learn mechanical energy of an object consists of at any instant is given as sum of its kinetic, which is represented as, and potential energies. Okay? So mechanical energy consists of these two parts, kinetic and potential energy.
So after whatever is not the E.
EK, that's the symbol. K is the subscript. Likewise, P is the subscript. So now we have to understand what is kinetic and what is potential energy. Kinetic energy. So, any idea what is the word kinetic means?
Used it in chemistry, did not know what it meant.
Something that is
That's yes, very good. That's why you have to come to physics class to make sense out of things. If you understand physics, your science life is easy. Because if you don't understand this, that is what make it difficult. So we'll decode everything, okay? So kinetic is
something which is moving.
moving, okay? So you said it. So what is kinetic energy? So it is the energy possessed. Where did you learn it? Kinetic.
Chemistry first chapter.
So something about motion.
No, but particles moving.
Moving. Okay. So anything moving is in action or has some kinetic energy. So it is the energy associated with moving object possessed by an object by virtue of its motion. Okay? It is the energy possessed by an object by virtue of its motion. For example, does this object has any energy? Stationary. Does it have any energy right now? Now if I will it hurt you?
Yes,
Why?
because for you work, so
It does work on you, right? It is trying to displace your head, but your head is there itself, so it will get wounded. Right? So if it hits and you move your head along with it, will it hurt you? A little less. Impact, rate of change of momentum. You increase time, the hurt will be reduced. Right? So, but it is trying to displace your head. It is trying to work in you. So, any moving object has the ability to do work. Because whenever it collides with the object, it tries to move the object. Got it? Yeah? So therefore it has energy. Otherwise it will not be able to work with you. If I gently toss, nothing happens. Right. Okay? So that's what it is. So how is it given? It is given as EK is equal to half mv square. So this is the expression for kinetic energy possessed by any moving objects. Any moving object. If a body has mass m and if it is moving with velocity v, then it possesses kinetic energy given by half mv square. That is the energy of the body. Okay? Mass times square of velocity divided by 2. So now we'll do the derivation. So everybody write till here, then we'll do derivation together. You took motion extra lecture, no? Motion or some other chapter?
Motion also motion.
Yes, completed, right? We covered everything?
Yes, sir.
So, anybody who has difficulty can book an extra lecture. Do that. See, I did entire chapter for her. So, motion में जिसको भी तकलीफ है और laws of motion.
Yeah, we did have an extra lecture with Ashutosh sir some
Yeah.
time ago. Me and
Is it?
Agnes had that.
Yeah.
For physics.
Acha, so it is still not clear?
No, it's
Clear,
for us
right?
it's clear.
So don't hesitate. If it is not clear, you say not clear. You need more help. So we'll do that. You have to ask for it. Only a crying baby gets milk.
Yeah.
So keep crying till the hunger is satisfied. Right? So you know it, right?
Can you run up the AC?
No. Next time you wear 2 jackets.
I am already wearing one.
Why? Do you have sugar issue?
No, I'm just cold in life, like in general.
Don't look like. Okay. Don't think about it.
That did not help that.
Are you serious?
Yeah. No, I am fine, Trisha. I am very fine.
No, there's no color.
That is colder.
Will be even more because the load is less. Shall we call him?
Yes, please.
Why don't you walk till the class and come back? You will lose your sleep also.
No, I'm not sleepy anymore.
No, you are. Go call him so that you will feel a bit energetic. Go to reception, Sandeep.
Yeah.
Ask him to do the job. Okay. It came, almost I thought it's lost. I pulled it back. So it requires concentration. Okay. So we'll do the derivation. how do we derive this?
Please come.
Yeah. Let's say you have an object whose mass is m. When the force is applied, right, it covers displacement s. Comes here. So what happens when you apply force on any object? Let us say it was moving with initial velocity u. Will its velocity change? Yes. है ना? When you fall, like तुम जा रहे हो तुम्हें धक्का दिया, तुम्हारा velocity change होगा, increase हो जाएगा. Let us say the new velocity is v. Because when you apply force, body gains acceleration, right? So it is accelerated in this direction. Correct? That's why the new velocity. So how do we derive the expression of kinetic energy? I told you, when work is done on the body, it gains energy, right? So whatever work is done on the body, that is its energy. Okay? From where this additional kinetic energy will come? Because of the work done on the body, correct? So whatever. So if a force is applied on a body of mass m moving with velocity u, then the work done on the body appears as its kinetic energy.
So then is it for all kinds of objects or only
All,
moving objects?
all, right? So obviously it has to move, otherwise no energy, because motion has to be there, no? Right? So that is, so therefore, what is the work done? It must be equal to F into S. You applied force, it caused displacement in its direction. The work done is force into S. And what is force given as? Mass into acceleration. Into how much displacement will be there? So you got initial velocity u, you got final velocity v, you got acceleration, you got displacement. What's the relation between four of these? Huh?
V square is equal to u square plus 4s.
Very good. So what will be S therefore? Correct? Okay, so this is by third equation of motion. S is equal to this. Since how we got this? V square is equal to 2as. Therefore V square minus U square equal to 2as. Therefore S is equal to this divided by 2a. Okay, this is how we got this. So what will we get now? So we get a cancelled. So we'll get half m v square minus u square. So work done on the body is half m v square minus half m u square. Okay? But what is half m v square? E kinetic, right? So this must be then final kinetic energy, and this is the initial kinetic energy. Okay? What is half m? So we will write it as work done You should write as change. So it is a change in kinetic energy, right? As you write change in its because since the body was already moving with velocity u, so obviously it should have some initial kinetic energy because every moving body has energy, and by working on it, you are bringing in change in the kinetic, right? So that's what we get. So this is E kinetic final minus E kinetic initial. This is what we get. So where EKF half mv square, the final kinetic energy. K is kinetic energy, okay? Ke and Eki is equal to half mu square is the initial kinetic energy. ठीक है? Now, what if u was equal to 0? So if u was equal to 0, that is, if the body was initially at rest, then the work done on the body will be its kinetic energy, right? There is no change. Then W is equal to half mv square, or E kinetic is equal to half mv square. Right? So if the stationary body is set into motion, then whatever work is done on a stationary body, that appears as its kinetic energy. Okay? That's what it is. So this is the derivation of. Now what is there which is so difficult that you're giving me such a scary face? It's not difficult, right? Just read it, take your time, read it. Note it down, please. हिंदी में बोलो ये क्या हो गया समझ में आएगी नहीं डिराइव कर लो ये क्वेश्चन आता है Done writing?
So that's the EK.
F. Final kinetic energy. E क्या is initial kinetic energy. मतलब जो velocity final velocity है तो final kinetic energy. Initial velocity तो initial kinetic.
Start.
नहीं, that's नहीं. F, small f. Shall we proceed? So next is potential energy. So what is potential energy? Now look here. Whenever a body's position is changed, right, then also it has energy. So energy possessed by a body by virtue of its position or configuration. Now what is configuration? Let's say we have a spring, right, or a rubber band. If it is relaxed, it has no energy. But you stretch the rubber band and now leave it. What happens?
It has energy.
It has energy, right? It will hurt. Why I'm using the example of hurt is because that is when you can feel, right? So, or in a gun, when the trigger is pulled, when you release the trigger, that's when the bullet moves. So, pulled trigger has potential energy. Okay? So that's change of configuration. Okay? Any deformity has potential energy, right? For example, this is the normal position, let us say. If I pull it back, when I leave it, what happens? Comes back, right? So any elastic object, so I can, okay? So I'm able to hit it, something like that. So if it is a spring, etc. So the spring stretched, that is change of configuration. Normal is relaxed spring. If I compress a spring, then also it has potential energy. So what is potential energy? So it is defined as the energy possessed in our days. We can't dare to do this, yeah. We can't dare to do this in our days. It is defined as the energy possessed by the body by virtue of its position or change of configuration. Change of configuration. Now see, when the object is lying on the table, does it have any energy? Does it have kinetic energy? No, because it is not moving. Does it have potential energy? No. Now what I do is, I lift it here. Does it have potential energy now? No? Yes, no?
Yes. Yes.
Why?
No. Because it changes position.
Yes, the position is now changed. So in changing position, what did I do on the object?
Just light energy.
Huh?
Light energy.
Did I work on it?
It changes position.
I applied force on the object in the upward direction and it moved also. So did I work on the object? Whatever work I did gets stored in its potential energy. So whenever you work on an object, that work done appears as its energy. Now, why are we calling it potential? Because now it is due to change of position. Is it clear? So now there is a trick. Look here. When I move this object like this, what energy it has got? It has only kinetic energy, right? Why not potential energy? Does it have potential energy?
Yes. No.
No, because its position is on the ground only. But if I take it above the ground, I am moving this object against some force. What is the condition for potential energy? The work has to be done on the body against some force. So which force is acting on the body? Gravitational force. Now I am working on this object against gravitational force, then it will have potential energy. Likewise, in a rubber band, when I am pulling the rubber band, I am working against the restoring force. Whenever you stretch a rubber band, what happens? Or a bow and string, right? So when you put an arrow and when you pull the string, that's when the string gets potential energy. And when we release the string, the potential energy in the string gets converted as kinetic energy of the arrow. ठीक है? समझ आ गया? So when do you get potential energy? When you are working on an object against some force acting. Clear? Okay. So the next topic is gravitational potential energy. Is stored in the object when the object is lifted or moved up against gravity. Okay. So let's say we have an object on ground. This is ground. That's the object of mass m. So when it is lifted up, let us say, what is the force applied? It should be at least equal to its weight. At least. Right? And let us say it is lifted till height h. This height is h. Right? And then the object is brought here. So what is the potential energy in the object? So potential energy in the object is equal to work done in lifting the object against gravity. So how much is the force F? How much is the displacement H? What is the vertical displacement? H. How much is the force? At least mg and H. So this is the potential. Is it clear? Okay, so today we learned what is so So here also, this is force times vertical displacement. Work done definition is same, right? So what did we learn today? Work.
Energy, types of energy.
Yes.
Unit
Kinetic
of work, mechanical energy, types.
These three things.
Kinetic energy is derivation and potential energy.
So what is the formula for work? Force into displacement. Right? Or force into vertical displacement. Okay? What is this formula? Half
Half
and
mv squared.
what about this?
Energy.
These three things we learned. Apart from this, we learned the units. What is the unit? Joule. Joule. Energy is always measured in joule. Same unit as work. Okay? So how many lectures you have today? Just one? Go home, sleep.
No, most of one maths also then MBBS.
है फिर क्या बोल रहे हो बात? अच्छा one physics. Okay.
किसने किया है? किसने किया?
क्या
मैथ्स का होगा
लिखना था ना एक बार शीट पे नहीं कोई बात बता यार
एक बात बता एक किया
सुबह स्कूल बहुत लिखा है
चांदी से पहले करने में यार
इससे सब लेट होते हैं ना लेकिन आज जल्दी है आज
लोग कहाँ बैठ रहे हैं हम लोग
तू आगे आ जाएगी
कौन ए अभी मत सीट चेंज कर अभी मेरा वही सीट रहने दे वो ऐसे भी आगे बिठा दे
Oh yeah, you do that in Pakistan.
अरे तुम सबको वैसे ही अलग बैठना है
Feel like you don't go. Why don't you not understand it? I'm not. ये तो आ जाएगा बहुत इजी नहीं है बहुत लेना पड़ेगा लेकिन हो जाएगा